When we hear the word bias, our first thought might be of something negative or unfair. However, in the fascinating world of deep learning models, bias has a completely different and profoundly positive role. It is not about prejudice, but about precision and flexibility. The primary purpose of biases in deep learning models is to allow a model to shift its activation function, enabling it to learn patterns that are not dependent on any input features. Think of bias as an adjustable intercept that provides the model with extra flexibility to fit a wider range of data distributions. In a neural network, each neuron receives a weighted sum of its inputs. The bias term is an additional constant that is added to this weighted sum before the result is passed through an activation function. This constant allows the activation function to be shifted left or right on the number line, independently of the input data. Without bias, the activation function would always pass through the origin, severely limiting the model's ability to representing complex relationships and fit diverse datasets. To fully appreciate their utility, consider how a model might differentiate between two classes of data points. By adjusting the bias, the model can effectively shift the decision boundary, allowing it to correctly classify data even when the input features themselves are all zero. This means the model can learn an output even in the absence of any input signal, which is critical for correctly modeling real-world phenomena. The concept of bias can be likened to the intercept term in a linear regression equation. Just as the intercept allows the regression line to cross the y-axis at any point, bias allows the neural network's activation to fire at different thresholds. This seemingly simple addition dramatically increases the model's capacity to learn, allowing it to move beyond trivial patterns and uncover intricate structures within data. It is a fundamental component that empowers networks to achieve non-zero outputs even with zero inputs, or to activate a neuron with specific input combinations. Ultimately, the clever inclusion of bias terms provides deep learning models with the essential adaptive capacity needed to effectively learn and generalize from complex data. It grants the model a degree of freedom that ensures it is not rigidly tied to the origin, enabling it to find the best possible fit for the underlying patterns in your data and make accurate predictions across a broad spectrum of scenarios.